What's up, math fans? Can you see this? Try to read it. It kind of says, it looks like it says chump, I think. But what if I spin it around through the center? Make it upside down. Now it says something, wait a minute, it still looks like it says the same thing. So what's my point? That shape or that word had rotational symmetry. All right, remember that. It's a rotation about the center, and the center of a graph would be called the origin. So if a graph has symmetry through the origin, meaning if I spin that graph upside down and it looks exactly the same, then it is considered an odd function. And if it has symmetry just over the y-axis, it's considered an even function. All right, so here's some things you need to know. We first learned odd and even powers, and that's really easy. You just look at the highest exponent, boom, that's if it's an odd power or an even power. But for an odd or even function, there's a lot more details you need to know. So for an even function, f of x would have to equal f of negative x. And this is an algebraic explanation, which I'm going to show you in a second. But the graphic explanation is simple. If they give you a function, you can look at it as a picture, you can type it in the graphic calculator and see it. And if it has symmetry over the y-axis, if f of positive x, you can see this red dot, f of positive x is that dot right there, f of negative x is that dot right there. So those have the same y values. They're both positive, whatever, 5 or something like that. If they're in the same y location, there's symmetry over the y-axis. You have a this side's even function. I'm gonna get to odd functions in a second. Okay, so let's be even more specific. The equation or the function I'm trying to show you is f of x equals, this looks like a parabola, so it's probably x squared plus, let's say, 1. Okay, and I'm gonna name this one also when I get to it. Maybe this will be g of x equals just plain old x cubed, just to keep it as simple as I can. So here, if I fold this parabola over the y-axis, does it land on itself? Is it onto itself? Yes, it is. It has symmetry over the y-axis, so it's considered an even function. It's as simple as that. If they ask you if something's odd or even, fold it over. If it folds over the y, it's even. If you spin it upside down, if I spin this thing upside down, this one looks exactly the same upside down. This one would be odd. All right? That's the graphic explanation. The mathematical or the algebraic explanation is a little more complicated. So f of x would have to equal f of negative x to prove that this is even. Or negative f of x would have to equal f of negative x to prove that it's odd. What am I saying? Pick a number. Let's say this was 3. So f of 3, I'm picking a random number here, it could be any number, would have to be the same as f of negative 3. F of negative 3. If this comes out to the same as this, I've proven that I'm looking at an even function. So let's see, f of 3 means take the 3, square it, and then add 1. 3 squared is 9. 9 plus 1 is 10. F of 3 is 10, okay? F of negative 3 means take the negative 3 squared. A negative number squared is positive 9. And then I still add 1, because that's my function. And that still gives me 10. So I got the same answer, 10 equals 10. If f of anything equals f of the negative of it, you're looking at an even function. So I proved it graphically just by folding it over, and now I proved it algebraically. Okay, let's look at this guy. Spin it upside down, looks the same, I'm done, it's odd. But if I have to prove it mathematically or algebraically, let's pick, my favorite number is 3, I'm gonna pick 3 here. So this time, negative f of x, or in this case, maybe I should say g, negative g of x would have to equal g of negative x, okay? So negative on the outside would have to give you the same answer as negative on the inside. But I'm going to pick my favorite number, so I'm sticking with 3. So negative g of 3 has to be the same as g of negative 3. Negative g of 3 means do g of 3 and then make the answer negative at the end. So I'm going to ignore that negative and just figure out g of 3. So that means take 3, plug it in here. 3 cubed is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So g of 3 is 27. Drop down the coefficient negative, making it negative 27. Is that equal to, let's figure out what g of negative 3 is. Negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. So look at that. Negative g of x equals g of negative x. So that worked out. All right, it sounds more complicated than it is. Basically, it's pick your favorite number, plug it into this, plug it into here, and then negate it. That's this one. Or take your favorite number, make it negative, plug it into here, and see what happens. If they're the same, you got an odd function. So I just proved that this is odd. All right. Now I'm going to prove that it's not even. How do I do that? In order for it to be even, it would have to fit this formula. So I'm using g on this side. So g of 3 would have to equal g of negative 3. G of negative 3. Let's do it. G of 3. That means I take 3 and plug it in here. 3 to the third power, we just said was 27. Is that equal to g of negative 3? So negative 3 to the third power is negative 3 times negative 3 times negative 3. We said was negative 27. Does this equal this? Does this equal this? No. So it's definitely not even. It's only odd. Is it possible to be both? 1 in a million. Very rare. I think there's only actually one function that's both odd and even. Generally, it's either odd or even or neither. Most functions are actually neither. Here's a simple example. I take my parabola, I slide it over and let it, instead of floating on the y-axis, it's now floating over here. That's not symmetric to the y-axis because there's nothing even on the other side of the y-axis. So once you pull it off the y-axis, it's no longer symmetric to the y-axis. It's no longer odd nor even. So only specific cases are even, only specific cases are odd. Most functions are neither. And again, there's that one rare case that it is both. Okay, so here's how to prove it algebraically. Here's how to prove it graphically. You just point and say, look, spin it upside down, it's done. You might get some complicated questions like, is f of x plus g of x, is this even or odd? And what you would have to do is take this and add it to this. And the sum of an odd function plus an even function is actually neither, okay? They might ask you, is f of x times g of x even or odd? So you might have to take this and multiply it by this, a little bit of distributive property, and then test if that's even or odd. And guess what? A even function times an odd function is also neither, okay? So you can play with it and see what happens. Let me rephrase what I just said. So an even function times an even function is actually an even function. An odd function times an odd function is an odd function. Misspoke again, let me write that down. Even times even is even. And odd times odd is actually also even, as an even function. And this one, even times odd, would be an odd function. All right? Don't believe me? Check my work. Thanks for watching. See ya.